Good afternoon, everyone. I'm Vibha Rustagi. I'm the SVP and Global Practice Head for IoT and Engineering at Cognizant. Thank you, Ned, for joining us, and thank you all for joining our Fireside chat today. As the automotive industry navigates profound shifts, software-defined vehicles, connectivity, rapidly evolving customer expectations, engineering leaders are under pressure today to deliver innovation at unprecedented scale without compromising safety, quality, or cost discipline. At Cognizant, we are working with automotive and industrial organizations at this specific intersection where software, AI, and physical systems meet the realities of the safety critical execution. Today's conversation is about moving beyond experimentation to execution and what it takes to build intelligence into systems that operate safely in the real world at scale. I am delighted to be joined by Ned Curic, Chief Engineering and Technology Officer at Stellantis, who brings a rare perspective spanning hyperscale technology and global automotive engineering. I encourage you to stay engaged and consider how these perspectives apply to your own engineering and transformation journeys. If you have questions, please post them in the chat and we'll address them as many as we can. Ned, thank you so much for joining. And you've built a career at the intersection of Silicon Valley and automotive engineering, and I'd like to start there. You've led technology and engineering across very different environments, from Northrop Grumman and Microsoft to Amazon, Toyota, and now Stellantis. Now that crossover gives you a very rare vantage point. I'd like to start off by asking you a couple of questions. What fundamentally has changed in your thinking when you started building software-intensive, safety-critical automotive systems and systems that must last for decades, that withstand regulatory scrutiny, they operate seamlessly in the physical world and at a global scale? Over to you, Ned.
Thank you very much. Thank you, Vibha, for having me, and good to see you again. And pleasure to be here with you. You're right. I mean, it's kind of complex in automotive world. It's not as we just building a mobile apps. We put stuff together, and here we go. We have another 100 million users using a mobile app. It's a different world where you have completely different set of regulatory and safety requirements, and yet doing things at scale. We build and ship 6, 7, 8, 10 million cars a year, and just building a car that's such a big physical instrument object every 60 seconds or every 45 seconds or so, it's a marvel. So automotive industry is really complex, yet it scales in a physical world that's unsurpassed in that level of complexity. So it is not an easy thing, but it's very delightful and enjoyable thing to build something that moves, and it moves at a really, really high speed, and you do that at scale. Building the rockets, if you will, is very complicated, but building cars at scale to me is far more complicated than actually building the rockets. And a lot of times people, well, I'm a rocket engineer, well, I'm a car engineer. So it takes a lot to build the cars and do it, time and time over again, and with that sort of consistency and precision. And a software. That all kind of different software in a vehicle. There's a vehicle software, there's entertainment software, infotainment software, there's a mobile software, there's a backend software. So not all software is the same. So we sort of break that down to different types of development processes, mechanisms, engineering practices. It's been a really great experience, both at Toyota, at Stellantis, and my experience with Microsoft and Amazon was also wonderful, but different from actually building the physical objects that we do here at Stellantis.
Thank you. Thanks. That's it's very interesting. You mentioned rockets and automotive, and then building software in your previous in the technology sector. So what lessons would you say from the automotive engineering do you believe the big tech companies will be forced to relearn as their systems become more embedded in the physical world?
Yeah, so very few people actually understand that Toyota invented agile. Most of the people, if you ask today in the world of software development, who invented agile, they'll point to somebody in the West Coast and things like that. But agile methodology is not a software methodology developed on the West Coast. It's developed in '60s by Toyota. And so the software companies, the good software companies have learned a lot from actually automotive industry. Even at Amazon, even to this day, internally at Amazon, we use, Toyota nomenclature, Kanban and Encore and Gemba and things like that. And it is a fantastic software company. So is Microsoft, and they learn a lot from automotive industry. It's not that they're learning now; they have been learning for a long time from automotive industry. But I think we had a disconnect is a lot of new startup companies, that the sort of software only companies that haven't had a chance to scale in the physical world. These companies struggle to understand the importance of a safety and regulatory framework that is immensely important in automotive industry, or anything actually that moves at a high speed, or any speed on the public roads or public environments. It does require to be immensely safe. You're driving a car 100 kilometers, 100 miles an hour. That car, when you push the brake, needs to stop. When you turn the steering wheel, it needs to turn the steering wheel. The engine needs to work a couple 100,000 miles. So there's a lot of, I want to say, constraint, both regulatory, but also physical, mathematical, lots of endurance, a lot of environmental factors. So when you build a computer for the data center, it's very different computer from the computer that sits in a vehicle. It's got a CPU, it's got the memory, it's got an I/O, but that computer is very hardened, so it can work, at 100 Fahrenheit or 140 Fahrenheit temperature. But it has to work in the freezing temperature. The cars needs to start minus 20 degrees Celsius and start, at the 45 degrees Celsius. So the software and electronics built for the vehicle for embedded system is quite more rigorous than the software and electronics built for consumer devices, for example.
Yeah, and this kind of difference in mindset you mentioned, the safety regulations, the rigor that at which it's moving fast. It becomes, especially clear when we look at how the industry itself is transforming, and it's shifting from hardware-defined to software-defined vehicles. Yet, many OEMs today still operate with deeply hardware-centric engineering cultures. So how do you realistically rewire an organization at that scale across
Right.
products, planning, talent, operating models, while also considering the regional needs?
Right, right. It's very interesting what happened. You have to go back and understand automotive industry a little bit. It's not so much it's a hardware centric versus software centric, and I understand there's a I want to say optics out there about hardware centric and software centric. I don't think from my perspective, it's not accurate. What has happened historically is that traditional car companies have outsourced most of the module development to third parties. So, when you build a car, you end up having historically in the car companies, you build various different modules and you tie them together into like some sort of operating framework at the level of the car. So you have a brake module, you have a steering module, you have a suspension module, you have a body controller module, you have engine controller module, and so forth. And these modules have been developed by various different suppliers, because you, as assembler of these parts, you buy a transmission from one supplier, you buy a suspension from another supplier, steering wheel from another supplier, because historically we outsource that work. And then that software that comes with these modules had to be then integrated inside the vehicle. And so the hardware would come. So you would think about, it's a hardware centric module. No, there's still a software that operates this hardware, but then integration became a very challenging because every software is written a little bit differently, actually a lot differently, and then you end up with this challenge of integrating. Now, if you were to have a green a slate or green sheet, you wouldn't do that. You would have it sort of central compute, and then with central compute would control all of these different devices in a car. And that's why, companies, the new modern companies started from that sort of a clean sheet. So then they have to buy a, piece here and piece there and so forth. They said, well, we're going to just build our own, or I'll just buy this piece of hardware, but this controller. I will not have the controller in a steering system. I'll use my controller to control this steering pump and so forth. And so the model has shifted. That was the old model the car companies had, but then outsourced to achieve the scale. Now we all going back to essentially owning that sort of engineering of the system, which I think we're doing right now, and then buying the components that we're going to buy or we build. So I'll give you an example. We used to buy computers from a supplier. We would specify the computers, we buy a computer, and they do their own ingredients, software ingredients, and we do integration. We don't do that anymore. Basically, we say, okay, we want to design our own computer, all our compute. We're going to put an IO, we're going to put a memory, we're going to put a chip. We're going to design how the system should look like, how should they integrate with the rest of the components of the vehicle. And then we're going to get a scale manufacturer like a Quanta to build this computer for us. So that all happened last couple of years, but we all have changed. So now you would say, well, this is a hardware. Yes, the hardware is very important. The software in the car is irrelevant unless you have amazing hardware to power that vehicle. So I wouldn't call it hardware centric, software centric. I would just say you design a system the way it should be designed, and not the way that we sort of moved away from designing how it should look like in automotive industry.
So thank you, Ned. As you mentioned, it's a combination, and it's not specifically hardware centric versus software centric, but there is a transformation that's going on in the industry towards that. And as you mentioned, you are also looking at, some of the components and then building that, integrating that. So at Stellantis, I mean, this transformation is playing out across multiple brands, across markets and energy strategies. So with the shift towards a multi-energy strategy under new leadership, how are the Stella platforms and Stella Brain evolving to support like all the powertrains from combustion to hybrids to, battery EVs, and while maintaining still the performance, the cost discipline, and alignment with the customer demand?
Great question. Really, really good question. And I think well-informed question as well. I think building the electric vehicle is very different from building the hybrid vehicle or gas vehicle because of how you integrate powertrain system inside. The electric system, believe it or not, is very simple and straightforward to integrate together with the body of the vehicle, the steering system, the braking system, and so forth, because the electric machine gives you the high precision control, how you integrate the torque to the rest of the vehicle versus the gas power, the hybrid systems are far more complex because you're dealing with the gas engine. You have to calibrate the controllers on a gas engine. You have to calibrate the controller on a transmission. And if it's a hybrid, becomes immensely more complicated. So you're dealing with a lot more variables and parametric sort of definitions to integration. It's not an easy thing to do, but what we have done, we laid out our brain architecture in such a way that we have a controller unit for the electric drive system and a controller unit for the gas and the hybrid systems. And then we have normalized set of interaction models between the vehicle body, chassis, braking, steering system with the propulsion systems on the electric drive modules and a gas. And so this sort of interaction model, we try to normalize a set of well-defined, API contracts between these between the interfaces to sort of simplify what's happening with the overall system. And it's working for us. We're launching a brain. We're actually driving the car now with the brain, the electric vehicles first. A month and a half before we actually integrated the gas and hybrid systems on exactly same vehicle, we call vehicle operating system in the brain. It's very powerful concept and it works really well. It's once when you lay out architecture properly, when you define your contract between the APIs really well, you define your specifications really well. Actually, it works quite well. I know some other car companies have struggled in this space significantly. For whatever reason, maybe we were just simply lucky, or we had a good engineers to design a system in a way we did. We are not seeing that struggle as much as maybe some others have seen it.
Yeah, well, that's great to hear. I'm sure it's a combination of good engineering capabilities and teams. This leads to a lot of the discussion nowadays or the noise around AI in automotive today, right? From autonomous driving to in-vehicle assistance, infotainment to AI-powered design and engineering. So how are you leveraging AI and data at scale across such a large organization?
Yeah.
And where do you see AI delivering the most meaningful impact? Is it on products, on engineering, quality,
Yeah.
operations?
It's absolutely amazing what's happening. I refuse to call it AI, although I did work at Amazon and Alexa, but I never called it AI until, the large language model came out, and that was just shocking. It is a truly AI type of systems. And so I changed my opinion on that, moved from machine learning to the AI. And we have, as soon as of course, the LLM, came out, we've been relentlessly deploying it and learning and deploying at scale. We have over 100 active applications today at Stellantis. To give an example, in simulations, we now simulate against synthetic models the data that we collected from the past on simulation. So we test now any sort of a mesh design against the simulated data. We don't actually run a full simulation, and we get 98% accuracy, like a 300 times improvements. The things that used to run days now run a couple of minutes. The things that would run for hours now run in seconds. So when you're designing, let's say, a mirror, designing a front bumper, we just run it against the simulated system, and so we get immediately feedback, coefficient, drag coefficient, or how it looks like on the system. So the designers and engineers now work together, immediately making changes. So you have a mechanical engineer, a designer, and manufacturing engineer working all together in the same shop to design the tools, and so the rapid evolution in the design has dramatically changed the way we actually plan and build a vehicle. So we're shrinking the time of designing and building vehicles. This is one example of really tens and as I mentioned, 100 example that we have in a product development, supply chain, purchasing, distribution, parts and services, everywhere inside the company. We're deploying the AI-based applications. It's been a quite extraordinary. Obviously, the data is key here. We recognize that early on. We have a couple hundred actually, people that just works on the data pipelines, and fixing the data or data engineering teams. Quite often, people talk about all these models and these things, but even if you talk to OpenAI or Anthropic, most of their investments are going actually in the tools, in the data, and making sure that the pipelines are good. And we did that, at Amazon, of course, and my previous jobs. The data pipeline and data engineering is the most critical part of the data, and that's where we spend a lot of effort.
Oh, thanks for sharing that. Certainly you mentioned the efficiencies and the speed at which this is making the impact in the industry and at Stellantis. And as you look ahead and as we move towards, physical AI, intelligence that must perceive, that must decide, act in real time in safety critical systems. What's the biggest shift you expect in automotive, let's say over the next few years? And what are the hardest constraints to solve to make this safe and scalable across the industry?
I think we have advantage, and I've been telling this since I joined Stellantis. I think car companies have a massive advantage over any other company in this world because we know how to build a hardware at scale. We know how to build 10 million cars at scale. We have a capability and a capacity to build very complex devices at scale. And AI for me is sort of easy. Compared to how you actually build a car completely. I just think about it, thousands of parts that go in a vehicle, and every minute or every 40 seconds, you ship the new car at scale. So I think the AI it's a sort of accelerator in safety, in usage, in control systems. I think it's a wonderful thing for automotive industry, and I think we're going to take advantage of that for sure. And we have a lot of programs in place to leverage all these advancements to make us even better. But I think if you go and ask, any sort of software company today, go build me 100 cars, it's going to be very difficult for them to build 100 cars, but we can build these models. We can use their models and put it in the cars and improve it and create a new opportunities for Stellantis, for sure. And that's a path we're on.
Yeah, and that's very insightful, and these transformations, as you've also mentioned, of this kind of magnitude, are not done in isolation, right? So as Stellantis drives, one of the industries I would say most complex transformations, software-defined vehicles, AI adoption, platform unification across 14 plus brands. So where do you see the most meaningful gaps, I would say, that external partners can fill faster or deeper than internal teams alone? And what kind of distinguishes a true engineering partner in this transformation journey?
I think the biggest help that partners bring to us is the really good thinking around engineering processes and the mechanism around the software and electronics engineering. I think it's not as we go through this transformation, we had existing process and mechanisms, pipelines, and so forth. It's quite outdated, and the modern software development does require modern tools, modern pipeline, and the knowledge in that space. And I think this is where the partners like yourselves and others can bring the highest value to accelerate, to clean the pipelines, put the new engineering pipelines in place to replace. We have a really good pipelines on the data acquisition. We invested a lot. Now we changing the process around software development and engineering, things like that. So I think that's where the biggest value is. We obviously we heavily using various different development tools, AI tools, so we're good at that. But I think we there's a room for us to improve significantly in the tooling, and I think that's probably the biggest area where partners can come in and help.
Oh, thank you, Ned. Yeah, and before we close, I'd like to step back and look at the industry more broadly. If you could make, one structural change in how the automotive industry approaches engineering and technology, something that would, I would say, decisively separate winners from laggards over the next 5 years, what would that be, and what's realistically slowing that change down today?
I think the traditional car companies have to insource most of the engineering. I think that there's a one thing that every car company is on the journey. There's a journey to outsource as much as possible. Now Chinese companies have done a good job. Essentially starting from a greenfield, and they insource that engineering capabilities and have this sort of different relationship with the tier one suppliers. There's still huge number of suppliers and partners involved, but the core capability is with the car companies around software and electronics and other elements. And I think that's a one thing that needs to happen for all existing car companies to sort of remove this dependency that is slowing down. To give an example, if I were to change the software right now and one of the existing legacy system in a controller, let's say a water pump controller or engine controller, it's going to take me 18 months with one of the suppliers to change the software. If I control that software in that controller, I can do that in 24 hours. And that's exactly what happens. We change the controller software for the modem because we designed that modem, we own it, or for entertainment system or a body controller in the 24 hours. And we can just do that over the air and be done with it. But I cannot change the software inside the engine ECU because it's not developed by me, and I cannot do that. And so that removing that dependency is the most critical thing for all car companies right now.
And are you seeing a lot of that in with other OEMs today? Are you seeing that transformation towards that journey today?
Yeah, they're all on the different stages of that journey. They're all trying to figure out how to do that. We on a one path, and I speak with my peers in other organizations that they have their own journeys, but just about everyone is on a similar journey.
Well, thank you, Ned. And I can't close this without one of my favorite questions is what is your favorite brand at Stellantis?
That's a great question. It's a tough question. We have brands like a Maserati and Alfa Romeo, and I love those cars, and Dodge and Jeep and Peugeot and Citroën, and I'm missing a bunch of them. But I love my Jeep Wrangler. I just, I joined the company because I love Jeep Wrangler so much. I enjoy rooftop down and taking it. It's a true freedom of mobility at beach, a mountain, off road, on road. It's just such a wonderful vehicle. So for me, it's the Wrangler. That's my favorite car.
Well, thank you. Thanks for answering that. And then, thank you for sharing such a, grounded and honest perspective on what it really takes to engineer intelligence, engineering it at scale in the real world, right? So what stands out is that the future of automotive isn't about a single technology shift. It's really about engineering and platforms, people, partners that all come together under real constraints. So these are exactly the kinds of conversations the industry needs more of, and we are delighted to convene this dialogue. Thank you, Ned, and thank you to everyone who joined us today.
Thank you, Vibha. Great to see you again.
Same here.